Okay, it's now on time. I would like to introduce myself first. My name is Sanghee Shin, and I'm from South Korea, not from North Korea. And then actually I'm a founder and the CEO of my company named Gaia 3D. So actually I'm just a businessman. I'm not a software engineer or a programmer. I'll talk about some software related works, but I don't know much about that. Anyway, it's my great pleasure to be here to share my company's long journey to use the open source GIS in Korean military sector. Okay, I'll talk about this kind of content today. And first, let's get started. Actually, 5 years ago, my client, Defense Geospatial Intelligence Agency, actually DGIA is equivalent of the United States NGIA, National Geospatial Intelligence Agency. Actually, they collect and produce and they process and they disseminate the lots of geospatial intelligence to the military officers. And 5 years ago, they made a very, very bold decision to replace the old proprietary software with the new open source software. And they hired us. So, and my company, together with the Mango system, we implemented the open source GIS-based geo-portal system successfully. And I made this kind of talk at Bucharest around 4 years ago. And then they named the new geo-portal as MilMap. MilMap is open source-based military geo-portal. So I would like to talk about the military geo-portal MilMap first. Actually, this is the MilMap's background and goals. As you see, actually, my client, DGIA, use many proprietary software, including Intergraph, including ESRI and other things. But they realized that they had too much dependency on the proprietary software. And at the same time, the license cost rise very rapidly, year by year. It was a very huge headache to the DGIA. Also, they want to lead to the increased access to the geospatial intelligence. Also, they want to disseminate their geospatial intelligence to other sectors as well. But they tried, whenever they tried to do that, they get the bill from the proprietary software company. So they made a bold decision. And then they hired my company and the Mango system. So at the time, the project goal was like this, and then the development of the FOSS4G based geo-portal, and then let's service all the geospatial data through the web using open source GIS. And then we successfully implemented all the things. This diagram is the logical diagram of the DGIA's MilMap. So there are lots of systems, production management systems, and other things. And then at the core, there is a MilMap. So we collect and process the vector data and the spatial imagery, satellite imagery, and the aerial photos and 3D data. And then we service all the data through to the military officers through the web. The only thing military officers need is just web browsers like Chrome or Edge or Opera. So this is the current MilMap's main features. MilMap provides this kind of things: information search and coordinate capture and analysis and intelligence management module. So I'll talk about one by one. Military officers can search many things: POI, address, map name, map number, and the national grid number. Also, they can capture the coordinate in multiple ways. Also, they can search many things via administrative level as well. Also, it provides many measuring tools, measuring distance, measuring area. Also, it provides 6 very basic analytical functions: radial line of sight analysis and linear line of sight analysis, profile analysis, and highest lowest point analysis, routing, threat dome, and the time series satellite image search and download. So current MilMap's system architecture is like this. Almost all the components are open source based one. So we heavily make use of the existing open source softwares: PostgreSQL, PostGIS, GeoServer, GeoTools, GeoWebCache. OpenGXT is also a geospatial analysis, and the geostatistical library is also open source. Also, Margo 3D is actually developed by my company. It's open source software. So we heavily use the existing open source software, and then we implemented the MilMap successfully. So actually, MilMap services the huge amount of the data beyond your imagination. They collect almost all the civilian geospatial information. At the same time, they have satellite images, spy images, lots of they have. And then we need to service this kind of data: vector data, raster and imagery data, and the 3D and others. So this is the MilMap's UI UX. So actually this is a 3D based one. So because it's based on the czoom.js. So on the left side you can see the two-dimensional map, and the right side you can see the 3D map. Also, just like a QGIS or other web map, our client can control the layer opacity, styles, colors, and other things. Also, they can change the background image also. Coordinate information. Coordinate is very, very important to the military. So they can capture the coordinates in various ways. Also, we support multiple coordinate systems: MGRS, UTM, degree and minute, degree, minute and second, also TM, and other things. Also, we support the multiple measuring units because not only military army, but also Navy and Air Force and Marines are using these systems. So we support the kilometer, meter, mile, feet, yard, nautical mile as well. And South Korea is a strong ally of the United States, so we should support this kind of the measuring unit and at the same time coordinate system. So this is a terrain analysis basic. I would like to introduce the basic terrain analysis here. Routing analysis also supports two kinds of routing options. It provides shortest path and then the optimal path. Optimal path considers the traffic light and then the road lanes, how many road lanes are there. And then also we make use of the PG routing. And this is a strap dome. It's very easy to implement using just a czoom.js. So far I introduced the current MilMap, and then we are hired once again to upgrade this system because over the last 4 years, this system, MilMap, has been hailed one of the best case of the transition from proprietary software to the open source software. And then we are hired once again, and we are currently upgraded this MilMap from 3.0 to 4.0. The change between from MilMap 3.0 to MilMap 4.0 is like this. Actually, over the last year, MilMap has served as a geo-portal very successfully. So many military officers are using these systems, but now a digital environment is changing very rapidly, so they want to use MilMap 4.0 as a digital twin platform. Also, main features are just exploring the data and the simple analysis, but they want to automate the data processing at the same time, very task-specific battlefield analysis. Also, as I already mentioned, the DJI has very many data pipelines. So, but it's not fully automated. So they want automate to some levels because it's very hard to automate all the things. Also, it just supports 6 types of the analysis, but in the MilMap 4.0, as I already mentioned, task-specific battlefield analysis will be provided. Also, MilMap 3.0 only run on the very high-end PC or laptop because it runs on the czoom.js and it requires a GPU or something like that to visualize very smoothly. But at the battlefield or there are lots of low-end PCs there in Korea as well, in the military side. So we support 3D, and then we support two-dimensional user interface as well. And we will support the personalization, and then unlike our expectation, this MilMap is very popular. So there are many people visit this site daily. So administrator who is in charge of this, in charge of managing this system, is complain about his burden. He have to manage many things, so he wants to add this kind of system status dashboard. So just a moment. So we have 4 major goals in terms of the MilMap 4.0. The first one is automatic data ETL, extract, transform, and loading. The second one is improved user experience. The third one is specific battlefield analysis and simulation. And the fourth one is personalization. So actually, as I already mentioned, there are lots of geospatial sources, and DJI wants to automate the kind of data pipeline. So we will do that, like that. Also, DJI's CRS is different from National Geographic Information Institute's CRS as well. So we need to convert the style, and we need to convert the coordinate system. So we have to automate many things like this. Also, improve the user experience as well. Also, intelligent PY search, other things. I'll talk about this in detail at the next slide. So this is the data processing pipeline. Imagine that there are lots of data processing pipelines for each data. There are 2D raster data from satellite images, spy satellites, and aerial images, and there are a bunch of data there. Also, there are production management systems. So they will usually collect the data and then also rectify, and they handle the metadata and store the secured database, and then we can access that database. Also, we can collect we should collect the overview and other things. Also, there are also lots of data, 2D vector data, including electric line and the electric pole as well. It's very important. Why that is so important, I will talk later. So anyway, we have to automate the many pipelines to increase the efficiency for the data preparation in DJI. Also, improve the user experiences. Actually, there are lots of POI data. So if you type in some location name, and there are so many things that popped up. Yeah, really. So we adapt the what's the name of the search engine? Elasticsearch. Yes, sorry. We adopt the Elasticsearch to increase the search efficiency. Also, left bottom side, you can see the satellite image. DJI received many satellite images, so they want to search and download these kind of things very easily. So right side, you can see the administrator dashboard, health stack, and other things. One of the main features of this MilMap 4.0 is that battlefield analysis, task-specific battlefield analysis. Actually, as I already mentioned, there are OpenGXD, that is a geospatial analytical library, also that provides geospatial statistics. So we make use of the WPS. So by using each atomic function as a building block, we create many task-specific battlefield analysis like this. So let's imagine there are lots of battlefield analysis for the military, but I got some examples, for just 3. Let's imagine that you have a main battle tank, or if you have IFB, and then you need to check whether our tank or IFB can move to the plane or not. So its basic logic is quite simple. We at first, we calculate the suitable length and less unsuitable length, and then that is quite simple. So detailed version is like that. So if you intersect the slope map and then the vegetation map, you can get the suitable area, and then if you union the, for example, water, wetland or swamp, and then the urban area like buildings, houses, and then the lake or river, and like this, and then you can calculate the field mobility analysis. Also, airborne infiltration analysis is also like this. So you can see the electric line as well. So some guy jumped into the here, but you should be aware of the electric line or other things. So there are this kind of algorithms are available in DGIA, and then we implement this using a WPS. Also, web printing is quite important in a real battlefield. So our user can design their own map like this, and then their analytics result here, and then they can print out, not using your printer or plotter. If you print button, if you click the print button, geospatial PDF will be produced, and you can download the geospatial PDF. So we currently use MapFish for the geospatial PDF creating. Also, user data. There are lots of units in Korea, and they want to have their own data. So they also want to upload their data on top of the backdrop images. So we also support that kind of user data uploading. This is a logical architecture. So actually, I'm not a software engineer. I do not fully understand what these are meaning. And this system architecture basically how we use the open source GIS. Like you may see almost all the components based on the open source GIS. So we heavily use the PostGIS, PostgreSQL, and MyBatis Spring, and OpenGXT, CZoom, and OpenLayers, GeoServer, and all the things. Another one is that we expect that this system will go huge and huge. So currently we redesigned this system as a microservice architecture one. So here we divided many services into several components like this, and then we currently implement a microservice architecture. This is also Microsoft architecture diagram. Also, using an interface gateway, many services will be served as just a module. So we can easily attach and detach the service using this system interface and the microservice architecture. This is a landing page of the MilMap 4.0. We Koreans like this one. So, MilMap 4.0 project will be finished middle of next year. And then the next year, we expect this kind of outcome. Actually, we could not demolish all the proprietary software. We can't get rid of all the proprietary software. So we pursue the hybrid architecture. So open source software, at the same time proprietary software. Also, our client expects the reduced license fee. That was a very huge headache. And then also, we offer all the source code to our client, so they also expect the capacity building inside the military ICT division with open source as well. Also, as a MSA architecture, microservice architecture, we expect the easily expandable and customizable and manageable system. Also, we expect the process automation and the low-cost, high-performance system, and then lots of things. So, if you want to see the next progress of this project, please come to Seoul. FOSS4G Asia will be held in Seoul, and I'll give another talk about the progress of my project. Thank you so much. Any questions?